Hi there, I'm Tatsu, and I'm just thinking, starting to learn Rust programming language. And before starting it, I use the Rust programming language tutorial, so-called the book. Yeah. So, and according to the repository, the book is provided under Apache 2.0 or MIT license. Okay. I use it in my tutorial series. Yeah, actually, so I learned the language 3 or 4 years ago, but I forget almost everything about it. I no longer remember the language. And also I'm sorry in advance. I'm not so good at speaking English. So I I yeah, I will often stumble in reading tutorial, yeah, so synthesis in tutorials. And also I use Arch Linux and Shellfish, and desktop environment is GNOME. Yeah, so this is my environment. So let's get started. And I will use ZEditor. What? Okay. I recommend using Fishshell, by the way. That's very awesome. Even though it's not a POSIX, it doesn't have POSIX compatibility. The Rust, so let's get started. So the Rust programming language. This version of the text assumes you are using Rust 1.850. Let's check the version of Rust. 1.84. Okay. If you guys don't have Rust, you should visit the official website of Rust and install Rust app command and set path variable, environmental variable, and also install Rust compiler. The Rust compiler, yeah. Yeah, Rust chains. Rust provides usually use cargo instead of invoking Rust C directory. Yeah, I barely remember I used cargo instead of Rust C to build a project. Yeah. Next. Fourth, it wasn't always so clear, but the Rust programming language is fundamentally about empowerment. No matter what kind of code you are writing now, Rust empowers you to reach further, to program with confidence in a wider variety of domains than you did before. Take, for example, systems-level work that deals with low-level details of memory management, data representation, and concurrency. Traditionally, this realm of programming is seen as arcane, accessible only to a select few who have devoted the necessary years of learning to avoid its infamous pitfalls. And even those who practice it do so with caution, lest their code be open to exploits, crashes, or corruption. Rust breaks down these barriers by eliminating the old pitfalls and providing a friendly, polished set of tools to help you along the way. Programmers who need a deep down into lower level control can do so with Rust without taking on the customary risk of crashes or security holes, and without having to learn the fine points of a FICO toolchain. Better yet, the language is designed to guide you naturally towards reliable code that is efficient in terms of speed and memory usage. Yeah, I heard that language has a lot of functionality or traits, uh, features to for enables us to avoid memory leaks and so kind of so dangling pointers, some other issues, the pointer or memory related issues. Uh, yeah, so I often use C language, and I sometimes forget the free memory I uh, I occupied before, and that causes memory leaks, and that's not a that's not a good thing. And I heard Rust is as fast as C and C++. Yeah, I don't know that is truly accurate, but Rust is fast. Programmers who are already working with low-level code can use Rust to raise their ambitions. Okay, for example, introducing parallelism in Rust is a relatively low-risk operation. The compiler will catch the classical mistakes for you, and you can tackle more aggressive optimizations in your code with the confidence that you won't accidentally introduce classes or vulnerabilities. But Rust isn't limited to low-level systems programming. It's expressive and ergonomic enough to make CLI apps, web servers, and many other kinds of code quite pleasant to write. You find simple examples of both later in the book. Working with Rust allows you to build skills that transfer from one domain to another. You can learn Rust by writing a web app, then apply those same skills to target your Raspberry Pi. This book fully embraces the potential of Rust to empower its users with friendly and approachable text intended to help you level up not just your knowledge of Rust, but also your reach and confidence as a programmer in general. So dive in, get ready to run, and welcome to the Rust community. Okay. Introduction. Okay. Welcome to the Rust programming language, an introductory book about Rust. The Rust programming language has some right fast level software, algorithm mix and low-level control are often the odds in programming language design. Rust challenges the conflict to balancing powerful technical capacity and that current developer experience. Rust gives you the option to control low-level details such as memory usage without all the hassle traditionally associated with such control. Yes, memory management is kind of harsh. Who Rust is for? Rust is ideal for many people for a variety of reasons. Let's look at a few of the most important groups. And Rust is, so as the book says, Rust is basically a low-level language. Yeah, even though, it is, also used for web backend, web server, and so on. But so I assume Rust is often used in a very low level realm of programming, like so embedded system or kind of so CLI application and so on. And so building, so the language is so fast, and because of the language is so fast, and so memory and has the ability of memory safety, and so this Z editor is also written in Rust, and so I often use Arch, and Haru AUR helper is also written in Rust. So the language has been so gaining popularity recently. So I feel it. I feel that. Teams of developers. Yeah, actually, I'm not a professional developer. I'm just a student. Rust is for students and those who are interested in learning about systems concepts using Rust. Many people have learned about topics like operating system development. Yeah, so actually, so Linux, I heard there's some, yeah, movement to introduce Rust um, to the Linux kernel, Android kernel, and so on. The community is very welcoming and happy to answer student questions. Though through efforts such as this, the Rust teams want to make systems concepts more accessible to more people, especially those new to programming. Companies open source reports, people who value speed and stability. Yeah, speed and stability. Yeah, so the official team focus on these concepts. Rust is for people who crave speed and stability in a language. By speed, we mean both how quickly Rust code can run and the speed at which Rust lets you write programs. The Rust compiler checks ensure stability through feature additions and refactoring. This is in contrast to the brittle legacy coding languages without these checks. Yeah, so like C++, which developers are often afraid to modify by striving for zero-cost abstractions. I've never heard that. Higher level features that compile to lower level code as fast as code written manually. Okay. Rust endeavors to make safe code be fast code as well. Yeah, that's great. The Rust language hopes to support many other users as well. Those mentioned here are merely some of the biggest stakeholders of our Rust credit submission is to eliminate the trade-offs that programmers have accepted for decades for programming safety, productivity, speed, and ergonomics. Give Rust a try and see if its choices work for you. Okay, what this book is for? Yes, you're written coding as well. Yeah, so mainly I use C++ and Python, and sometimes use other languages, but mainly yes, in C. I work in C++. But doesn't make any assumptions about which one. We will try to make the material broadly accessible to those from a wide variety of programming backgrounds. We don't spend a lot of time talking about what programming is or how to think about it. If you are entirely new to programming, you'd be better served by reading a book that specifically provides an introduction to programming. Yeah, so not so, yeah, that seems not so user-friendly. How to use this book? In general, this book assumes that you are reading it in sequence from front to back. Later chapters build on concepts in earlier chapters. The earlier chapters might not delve into details on a particular topic, but will revisit the topic in a later chapter. Okay? Yeah. It's kind of long. Okay, so the more I go further, the more the content dive into the detailed part, maybe. You'll find two kinds of chapters in the book. concept chapters and project chapters. In concept chapters, you learn about the aspect of Rust. In project chapter, you build small project to get a prime, blah blah blah. Chapter with how to use Rust. So yeah, so I'll continue to read from front to back. Yeah, maybe I should do so. And appendix, there's no way to read this book. If you wanna skip, go for it. Yeah, you might have to jump back to our chapters if you experience any confusion, but do whatever works for you. Another part of the process of learning Rust is learning how to read the error messages the compiler displays. This is guided for working code. As such, we'll provide many examples that don't compile along with the error message. Compiler will show you in each situation. Note that if you enter and run a random example, even not compile, make sure you read the surrounding text to see whether the example you are trying to run is into error. Ferris. Oh, he's Ferris. Will also help you distinguish code that isn't meant to work. In most situations, will lead you to the correct version of any code that doesn't compile. Okay, this code doesn't compile. Compile. This code panics. Okay, this code doesn't produce the desired behavior. Okay, this information. Okay, getting started. Let's start your Rust journey. There's a lot to learn, but every journey starts somewhere. In this chapter, we'll discuss installing Rust on Linux, macOS, and Windows. So as I said, I'm using Linux, and I've already installed Rust. Writing a program that prints Hello World using Cargo, Rust Package Manager, and Build System. Yeah, I love the name. Installation. The first step is to install Rust. We download Rust app. I skip the chapter. Yeah, so I have Rust app and Rust C, like I checked before. Echo path. What? Cargo. Yeah, that's okay. Updating and okay. I'll update. Okay. Take a minute. Documentation. Yeah, this offline version of the book. Rust contains it, maybe. Okay, Rust C version 1.91. What? Anyway. Alright, now that you've installed Rust, it's time to write your first Rust program. Okay, I'm excited. It's traditional when learning a new language to write a little program that prints the text hello world to the screen. Yeah, so we'll do the same here. As a basic one, familiar with the command line. Yeah, so yeah, because I'm a Linux user, yeah, there's no problem about it at all. Creating a project directory. Yeah, I already created it. You start by making a directory to store your Rust code. It doesn't matter to Rust where your code lives, but for the exercises and projects in this book, we suggest making a project directory in your home directory and keeping all your projects there. Then we'll enter following commands to make a project directory, blah blah blah. Engineer, cd and enter directory. Okay, writing and running the Rust program. Next, make a new source file and call it main.rs. Main.rs. Okay, main.rs. And Rust files always end with the rs extension. Okay, if you are using more than one word in your file name, the convention is to use an underscore to separate them. Yeah, kind of snake case. For example, use hello underscore word.rs rather than hello word.rs. Okay. Now open the main rs file you just created and enter the code listing 1 1. Okay. Fn main print rn with exclamation mark hello world with semicolon. And save the file and go back to your terminal window and compile it. Main rs hello world. Okay, I've done. Yeah, this is binary or executable. Regardless your operating system, the string hello world should print to the terminal. Okay. If you don't see this output before, yeah, I successfully done that. If hello did print, congratulations, you officially written a Rust program that makes your Rust programming welcome. Yeah, I'm glad to hear that. Another thing about Rust program. Okay, another thing. Let's review this hello world program in detail. Here's the list piece. Here's the first piece of the puzzle. FMA. Because I use C language, yeah, that's kind of very predictable, very easy to predict. These line define function names main, and the main function is special. Yeah, it is always the first code that runs in every executable Rust program. Here the rest line declares a function named main that has no parameters and returns nothing. If there were parameters, they would go inside the parentheses. Okay. The function body is wrapped in curly braces. Yeah, Rust requires curly brackets around all function bodies. It's good style to place the opening curly bracket on the same line as the function declaration, adding one place in between. Yeah. Rust FMT is a formatter. If you wanna stick to 7.7 for Rust FMT, Rust FMT format a file operating the original file in place. What? This is the editor's functionality. Maybe. Anyway, the volume the main function holds the foreign code. This is, yeah, I remember this is macro. What? My earphones battery. Sorry. What? Sure. Oh, what? What? 70%. Yeah, okay. Yeah. Oh, sorry. So it does all the work in this little program. It prints text to the screen. There are three important details to notice here. First, print around calls a Rust macro. If it had code a function instead, it'll be entered as print and without the exclamation mark. So without the exclamation mark, it should be called a function, but this is a macro, maybe. Rust macros are a way to write code that generates code to extend Rust syntax, and we'll discuss them in more detail in chapter 20. Okay, for now, you just need to know that using exclamation mark means that you are calling a macro instead of a normal function. That's macros don't always follow the same rules as functions. Okay, these are different. Okay. Second, you see the hello string. We pass this string as an argument to print around, and the string is printed to the screen. Yeah. Hello. Again, hello. Yeah. Third, we end the line is a semicolon, which indicates that this expression is over, and the next one is ready to begin. Most lines of Rust code end with a semicolon. Yeah. This is yeah. So in this is the same in most other languages. Comparing and running are separate steps. Yeah, you've just run a newly created program, so let's examine each step in the process. Before running a Rust program, let's compile it using the Rust compiler by entering the Rust C command and passing it the name of your source file like this. Yeah, so in C language, so GCC, I use GCC, yeah. And here Rust outputs a binary executable here, yeah. On Linux, you can see it's by entering the ls command, yeah, yes. Oh, Windows dear. Yeah, actually I'm so comfortable with Windows command line, okay, so PowerShell, yeah. This shows the source code with the RS extension, the example, blah, 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 blah. Oh, backslash on Windows. Yeah. If your main RS is your blah, blah, blah. If you are more familiar with dynamic language such as Ruby, Python, or JavaScript, it might not be used to comparing the running a program as separate steps. Rust is an ahead of time compiler language, meaning you can compile a program and give the executable to someone else, and they can run it even without having Rust inside. If you give someone a RB, Py, or JS file, they need to have a Ruby, Python, or JavaScript implementation installed. But in those languages, you only need one command to compile and run your program. Everything is a trade-off in language design. These languages are relatively slower than Rust because of the language design. Just comparing with Rust is fine for simple programs, but as your project grows, you want to manage all the options and make it easy to share your code. Next, we'll introduce you to the Kaggle tools, which will help you write real-world Rust programs. Okay. Hello, Kaggle. Yeah, hello. Kaggle is Rust's build system and package manager. Most Rustaceans, yeah, Rustaceans use this tool to manage their Rust projects because Kaggle handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries we call the libraries that your code needs dependencies. Uh, Cargo is like npm or like so some other I don't know other another example. The Rust users are called maybe Rustaceans. Yeah, like so Pythonists or so JavaScripters or something like that. Maybe the simplest Rust programs like the one you've written so far don't have any dependencies. Yeah. If we had built a Hello World project with Kaggle, it only used the part of Kaggle that handles building your code. As you write more complex Rust programs, you add dependencies, and if you start a project using Kaggle, adding dependencies will be much easier to do. Yeah, so dependency resolvement is very hard in programming, in my opinion. Yeah, because the vast majority of Rust projects use Cargo. The rest of this book assumes that you're using Cargo too. So yeah, so I'd always use Cargo. Cargo comes installed with Rust if you use the official installers discussed in the installation section. If you installed Rust through some other means, check whether Cargo is installed by entering the following in your terminal. Okay, Cargo version. Okay, I have it. If you see a version number, you have it. Yeah, I have it. If you see an error, blah blah blah. Okay, creating a project with Cargo. Create new. Cargo. I remove these files. Sorry. Bye bye. And so Cargo new hello Cargo. Yeah. Okay. And enter. Okay. I see main arrays and Cargo. Tomo. Okay. Oh. Let's see. The first command creates a new directory and project called Hello Cargo. Yeah, obviously. We've named our project Hello Cargo, and Cargo creates its files in a directory of the same name. Yeah. Go into the Hello Cargo directory and list the files. Yeah. You'll see that Cargo has generated 2 files and 1 directory for us. A cargo.toml file and a SRC directory with a main.rs file inside. And it already has the code to produce Hello World. It has also initialized a new Git repository. Oh, is that so? No, there is a, oh yeah, Git. Initializing Git around with a Git ignore file. Oh, yeah, yes. Git files. It ignores the maybe the product of the executables and so on. And we will also ignore the directory when I git add. And git files will be loaded if we run cargo. Yeah, okay. Cargo toml in your text editor of choice. Cargo toml. Yeah, toml file. Yeah, it should look similar to the code. Yeah, exactly the same. Yeah. This files in the Tom's obvious minimal language format, which is Cargo's configuration format. Okay, the first line package is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. Okay. The next three lines set the configuration information Cargo needs to compile your program, the name, the version, and the edition of Rust to use. Rust edition and version name. Okay. The last line, dependencies, is the start of a section for you to list any of your project's dependencies, like so libraries, so-called crates. Yeah, maybe. In Rust, packages of code are referred to as crates. Yeah, we won't need any other crates for this project, but we will in the first program. No, first project in chapter 2. So we'll use this dependencies section then. Now open SOC main RS and take a look. Cargo has generated a hello world program for you, just like the one we wrote in listing 1.1. So far, the differences between our project and the project Cargo generated are that Cargo places the code in the SOC direction, and we have cargo.toml configuration file in the top directory. Cargo expects your source files to live inside the SOC directory. The top level project directory is just for readme files, license information, configuration files, and anything else not related to your code. Using Cargo helps you organize your project. There's a place for everything, and everything is in its place. If you started a project that doesn't use Cargo, as we did with the Hello World project, you can convert it to the project that does use Cargo. Okay, load the project code into the SSH directory and create an appropriate cargo.toml file. One easy way to get that cargo.toml file is to run cargo init. Yeah, like git init, which will create it for you automatically. Yeah. Building and running a Cargo project. Now let's look at what's different when we build and run the Hello World program with Cargo. From your Hello Cargo directory, build your project by entering the following command: cargo build. Check. Cargo build. Compiling and finish. Okay. This command creates an executable file in target debug hello code. Target debug hello code. Yeah. Or target debug hello code rather than in your current directory, because the default build is the debug build. Cargo puts the binary in the directory named debug. You can run the executable with this command. Okay. Target debug hello Cargo hello world. Okay. If all goes well, Hello should print to the terminal. Running Cargo build for the first time also causes Cargo to create a new file at the top level, cargo.log. Yeah. And this file keeps track of the exact version of dependencies in your project. This project doesn't have dependencies, so the file is a bit sparse. You won't ever need to change this file manually. Cargo manages its contents for you. We just built a project with Cargo build and run it with /target /debug/hello cargo. And we can also use Cargo run to compile the code and then run the result and executable all in one command, which is very useful, very easy to use, convenient. Hello world. Okay. The same output. Using Cargo run is more convenient than having to remember to run Cargo build and then use the whole path to the binary. So most developers use Cargo run. Okay, I'll use it. Notice that this time we didn't see output indicating that Cargo was comparing hello underscore cargo. Cargo figured out that the files haven't changed, so it didn't rebuild, but just run the binary. If you had modified your source code, Card would have rebuilt the project before running it, and you would have seen this output. Okay, so I don't need to run Cargo build every time, and instead I should use Cargo run. usually. Yeah, Kaggle also provides a command called Kaggle check. This command quickly checks your code to make sure it compiles but doesn't produce an executable. Oh, just check. Okay. Why would you not want an executable often? Kaggle check is much faster than Kaggle build. So I know the build of Rust or the Kaggle is very heavy and yeah, and it seems taking a lot of time. Yeah, so because it skips the step of producing an executable. If you're continuously you're continually checking your work while writing the code using Kaggle check will speed up the process of letting you know if your project is still compiling. Such many Rust sessions run Kaggle check periodically as they write their program to make sure it compiles. Then they run Kaggle build when they are ready to use the executable. Okay, let's recap what we've run so far about Kaggle. We can create a project using Kaggle new, yeah. We can build a project using Kaggle build, yeah. We can build and run a project. It's one step using Kaggle run, yeah. We can build a project without producing a binary to check for errors using Kaggle check. Instead of saving the result of the build in the same directory as our code, Kaggle stores it in the target or debug directory. An additional advantage of using Kaggle is that the commands are the same no matter which operating system you're working on. So at this point, we no longer provide specific instructions for Linux and macOS versus Windows. Yeah, that's very good. Building for release. Kaggle build release, okay. Your project final ready to release, you can Kaggle build release to convert the optimization with optimization, okay. Without the debug mode, without debugging mode, yeah. This command will create an executable in blah blah blah. To the optimization make a Rust code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles. Okay. Kaggle as convention. Yeah, with simple project, Kaggle doesn't provide a lot of value over just using Rusty, but it will provide its worth as your programs become more intricate. Once programs grow to multiple files or need dependencies, it's much easier to let Kaggle coordinate the work, the build. Even though the Hello Kaggle project is simple, it now uses much of the real coding you use in the rest of your Rust career. In fact, to work on any existing project, you can use the following commands to check out the code using Git, change to that project directory, and build. Okay. I'm very sleepy. I'm getting sleepy. It's 3 a.m. Yeah. You're already off to a great start on your Rust journey. In this chapter, you've learned how to install the latest stable version of Rust using Rust app, using updates to a newer Rust version, often locally installed documentation, write and run hardware program using Rust directory, create and run a project using the conventions of Kaggle. This is a great time to build a more substantial program to get used to reading and writing Rust code. So, in chapter 2, we'll build a guessing game program. Yeah. If you would rather start by learning how common programming concepts work in Rust, see chapter 3 and then return to chapter 2. Okay, I just finished chapter 1. So today I'll finish the tutorial. So bye bye.